Yes, sir. You guys are D5. So yeah. We are discussing about concept of microprocessor, and I asked you a question from. So there is some guy remaining who are supposed to answer the questions. So from 25 to, I've asked question from 1 to 25, and the last number is 49. Okay. So today we're gonna discuss about bus, concept of bus. Then I think I have to change the slide. Okay, good afternoon class. So now we're going to start the concept of bus for today. So last time we discussed about a microprocessor. So can I ask some questions to you guys about microprocessor? So Karun Giri. Karun Giri.
Yes, sir.
So how are you today?
I am fine, sir.
Okay, you are fine. So can you tell me about what is clock speed in a computer?
Clock?
Speed or clock cycle? No? Okay, अलिकति मेहनत गर्नु पर्यो है स्टुडेन्टले मेहनत गर्नु पर्यो. ओके, क्लक साइकल भनेको चाहिँ नम्बर अफ इलेक्ट्रिक करेन्ट that is passed through electric that is passed through a chip in a second. It is usually measured in either is usually measured in hertz. The measurement unit is hertz, and usually it is measured in gigahertz. Okay, so let's talk about the bus. So we all know the bus. The bus is as a general, the bus is used for transportation of people and transportation of some goods. So in a computer system, a bus is a common pathway through which the information flow from one computer component to another. एउटा कम्प्युटरको कम्पोनेन्टबाट चाहिँ अर्कोमा चाहिँ तपाईको डाटाहरु अथवा इन्फर्मेसन फ्लो हुन्छ भने त्यो फ्लो हुने मिडियालाई नै के भनिन्छ? We call it bus. बस भनेर एउटा तपाईको चाहिँ स्ट्रक्चरल डिजाइन भएन कि तपाईको चाहिँ एउटा पाथ हुने भयो. पाथ फ्लो अफ सिस्टमलाई चाहिँ के भनिन्छ? बस भनिन्छ. अथवा this path is used for communication purpose and it is established between two or more computer component. Usually bus चाहिँ के लागि युज गरिन्छ भन्दाखेरि कम्युनिकेसन को लागि युज गरिन्छ between two or more devices or component को बीचमा चाहिँ तपाईको केही इन्फर्मेसनहरु ट्रान्सफर गर्नु पर्यो. इन्फर्मेसन युजुअली किन ट्रान्सफर गरिन्छ भन्दाखेरि for the purpose of communication. Communication को लागि चाहिँ usually we transfer information है. अब what is the function of buses in computer system भन्यो भने data sharing, addressing, power and time. These are the some common functions of buses in computer system. अब data sharing लाई अलिकति further रूपमा चाहिँ describe गरेर हेरौं. All types of buses found in computer transfer data between the computer peripheral connected to it. तपाईको हरेक टाइपको बसेसहरुले चाहिँ के काम गर्छ भन्दाखेरि they usually do the work of transferring data that for the different component of the computer that has connected to it. The buses transfer or send data either in a serial or parallel method of data transfer. भनेको तपाईको चाहिँ data transfer को there are two way in which the data is being transferred, that is parallel or serial. Serial भनेको चाहिँ if you transfer a data that is continuous basis मा चाहिँ डाटा ट्रान्सफर हुन्छ भने as the parallel मा चाहिँ के हुन्छ? The whole information is transferred in one cycle. एक साइकल मा चाहिँ तपाईको होल इन्फर्मेसन ट्रान्सफर हुन्छ भने सिरियल मा चाहिँ के हुन्छ? कन्टिन्युअस मा तपाईको स्टार्टिङ देखि एन्ड सम्म चाहिँ 1 by 1 गरेर ट्रान्सफर हुन थाल्छ. यसको बारेमा हामी अझै फर्दर एउटा भिडियोमा हेर्ने गर्छौं. This allow for the exchange of 1, 2, 4 or even 8 bit of data at a time. तपाईको चाहिँ यहाँ बाइट भनेको छ है, बिट भनेको छैन। त्यो मिनिङ के हुन्छ भने तपाईको 8 बिट अथवा 16 बिट अथवा 32 बिट अथवा 64 बिट चाहिँ डाटा चाहिँ एक टाइममा चाहिँ युजली ट्रान्सफर हुन्छ। तपाईहरुको बस चाहिँ युजली यसरी चाहिँ क्रिएट गरेको हुन्छ। 8 बिट चाहिँ किन गरेको भन्दाखेरि एउटा क्यारेक्टरलाई सिंगल युनिटमा ट्रान्सफर गर्दाखेरि चाहिँ यु एटलिस्ट नीड अ 8 बिट। एउटा क्यारेक्टरलाई डिनोट गर्नलाई हामीलाई कति चाहिन्छ भन्दाखेरि वी युजली नीड 8 बिट। सरी 8 बिट चाहिने भएर चाहिँ के हुन्छ भन्दाखेरि युजली स्टार्ट फ्रम 8 बिट, 8 बिटबाट स्टार्ट भएर इट विल गोज अन इन्क्रिजिङ बाइ द मल्टिपल अफ 8। 8 को मल्टिपलले चाहिँ इन्क्रिज हुँदै जान्छ। 8 हुन कसैको 8 हुन्छ, कसैको 16, 32, 64 एन्ड सो अन। Buses are classified depending on how many bits they can move at a same time. एक टाइममा चाहिँ कतिवटा बिट मुभ गर्न सक्छ भनेर चाहिँ बसहरुलाई युजली क्लासिफाई गरिन्छ। which means that we can have 8 bit, 16 bit, 32 bit or even 64 bit buses. Okay. अब एड्रेसिङ हुन जान्छ। When a user or a program needs information that is stored in a computer's memory, the address bus tells the computer where to look for it. अब तपाईले चाहिँ युजली सीपीयू अथवा कुनै प्रोग्रामले चाहिँ तपाईको कहीँ गएर के फाइल सेभ गर्नु पर्यो भने चाहिँ युजली बसेसहरुले चाहिँ के प्रोवाइड गर्छ भने दिस इज द लोकेसन दैट यू क्यान सेभ योर डाटा भनेर चाहिँ इन्फर्मेसन प्रोवाइड गर्ने काम गर्छ। अर्को कुरा भनेको पावर सप्लाई। A bus supplies power to various peripheral connected to it. तपाईको जुन पावर सप्लाई को काम हुन्छ नि त्यो पनि युजली इज डन थ्रु मिडियम अफ बसेस। बसेस को मिडियम थ्रुबाट चाहिँ पावर सप्लाई को काम गर्ने गरिन्छ। अर्को हुन जान्छ टाइमिङ। द बस प्रोवाइड्स अ सिस्टम क्लक सिग्नल टु सिंक्रोनाइज द पेरिफेरल अट्याच्ड टु इट विथ द रेस्ट अफ द सिस्टम। तपाईको चाहिँ बसेसहरुले युजली अर्को के कुरा प्रोवाइड गर्ने काम गर्छ भने टाइमिङ सिग्नल। केका लागि भन्दाखेरि इच एन्ड एभ्री जुन मिडियमहरु तपाईको डिभाइसेसहरु कनेक्टेड हुन्छ नि तिनीहरुलाई चाहिँ सिंक्रोनाइज एउटै टाइम सिस्टममा राखौं भनेर चाहिँ उनीहरुले टाइम सिग्नलहरु प्रोवाइड गर्ने काम गर्छ। सो दिज आर सम फंक्शन्स अफ बसेस। बसेस को फंक्शन भन्दाखेरि डाटा शेयरिङ, एड्रेसिङ, पावर एन्ड टाइमिङ। देन आफ्टर दैट दिस इज द पिक्चर अफ हाउ द बसेस वर्क। हजुर
पहिला सुरुको स्लाइड देखाउनु न एक्चुअली।
अगाडिको
यस सर। ओके सर।
हैन मैले तपाईहरुको स्लाइड ग्रुपमा राखिदिएको छु। सो यु क्यान राइट इट डाउन फ्रम देयर है। अहिले तपाईहरुले चिन्ता गर्नु पर्दैन, जस्ट लुक एट इट। मैले सबै स्लाइडहरु अपलोड गरिसकेको छु। So these are the pictorial diagram of the buses that is used in computer system. Computer system में use गर्ने बस को डायग्राम चाहिँ के हुन्छ? एड्रेस बस वन साइडेड हुन्छ किनकि युजली एड्रेस बस भनेको चाहिँ सीपीयू ले तपाईको मेमोरी अथवा कुनै पनि स्टोरेज युनिटमा चाहिँ यहाँ लगाएर सेभ गर्नु भनेर एलोकेट गर्ने भएर चाहिँ दिस इज वन साइडेड फ्रम सीपीयू। किनकि सीपीयू मा स्टोरेज हुँदैन, सीपीयू मा जन्नी मात्र हुने के हो प्रोसेसिङ हो। त्यसले गर्दाखेरि चाहिँ सीपीयू मा एड्रेस बस चाहिँ वन साइडेड हुन्छ भने डाटा बस कन्ट्रोल बसहरु चाहिँ टु साइडेडहरु देखाएको छ है। After that, let's talk about type of bus. Type of bus भन्दाखेरि there are usually 4 types of buses. The fourth one is an optional one. Expansion bus is an optional one. There is data bus, address bus, and control bus. Data bus ले चाहिँ usually के काम गर्छ भन्दाखेरि the data bus allows data to travel back and forth between microprocessor and memory. Memory र microprocessor को बीचमा चाहिँ डाटाहरु ट्रान्सफर गर्ने काम चाहिँ usually is done by data bus. अब एड्रेस बसले के गर्छ भन्दाखेरि अघि नै पनि डिस्कस गरिसकेको छौं। दिस बस क्यारीज द इन्फर्मेसन अबाउट द लोकेसन अफ डाटा इन अ मेमोरी। एउटा डाटाको चाहिँ मेमोरीमा कुन ठाउँमा लगेर राख्ने भन्ने कुरा चाहिँ इज युजली क्यारिड आउट बाइ एड्रेस बस। देन देयर कम्स द कन्ट्रोल बस। द कन्ट्रोल बस क्यारीज द कन्ट्रोल सिग्नल दैट मेक्स श्योर एभ्रीथिङ इज फ्लोइङ स्मूथली फ्रम प्लेस टु प्लेस। कन्ट्रोल बसले चाहिँ युजली के काम गर्छ भन्दाखेरि एउटा एक्नोलेजमेन्ट सिग्नलहरु पास गर्ने गर्छ, कन्ट्रोल सिग्नलहरु पास गर्छ, जसले गर्दाखेरि चाहिँ तपाईको चाहिँ जुन प्रोसेस चलिरहेको छ तपाईको ट्रान्सपोर्टेसन प्रोसेस चलिरहेको हुन्छ त्यो बेलामा चाहिँ कहीँ एरर नआओस्, यदि आएको कन्डिसनमा पनि फिगर आउट गर्न सकोस् भन्ने तरिकाले चाहिँ कन्ट्रोल सिग्नलहरु पास गर्ने काम गर्छ, जसले चाहिँ मेक श्योर एभ्रीथिङ इज फ्लोइङ स्मूथली फ्रम प्लेस टु प्लेस। And then there comes the expansion bus. Expansion bus is an optional unit. Message and information passes between our computer and the add-ons in board you plug in over the expansion bus. Expansion bus and तपाईले कुनै नयाँ बोर्डहरु थप्नु भयो, जस्तो जीपीयू हरु थप्नु भयो भने usually it uses expansion buses है। अब हामी यसको बारेमा फुल अन डिटेल्स चाहिँ केमा हेर्न जाँदैछौँ भन्दाखेरि एउटा युट्युब भिडियो छ जसमा चाहिँ तपाईँको के को बारेमा डिस्कस गरिरहेको छ भन्दाखेरि हाउ द बसेस आर बिङ मेड अनि वाट इज सिरियल ट्रान्सपोर्टेसन अनि वाट इज प्यारलल ट्रान्सपोर्टेसन वाट आर द एडभान्टेज अफ सिरियल एन्ड वाट आर द डिसएडभान्टेज अफ सिरियल एडभान्टेज अफ प्यारलल एन्ड भाइस वर्सा डिसएडभान्टेज र एडभान्टेज र डिसएडभान्टेज बोथ प्यारलल र सिरियलको हेर्न गइन्छ है यसमा चाहिँ तपाईँले अलिकति ध्यान दिनु होला किनकि तपाईँको यसो देख्दाखेरि चाहिँ प्यारलले एकैचोटि तपाईँको 64 बिट एकैचोटि 32 बिट ट्रान्सपोर्ट गर्न सक्यो भने त सजिलो हुन्छ भन्ने हुन्छ नि तर युजली अहिले जुन कम्प्युटरहरू युज गरिरहेको छ तिनीहरूले चाहिँ सिरियल युज गर्छ किन युज गर्छ भन्ने कुरा चाहिँ अपकमिङ भिडियोमा डिस्कस गर्न गइरहेको छ तपाईँहरूलाई चाहिँ यस्तो कन्टेक्स्टमा यदि तपाईँले यसमा भनेको कुरा अलिकति बुझ्नु भएन भने चाहिँ यु क्यान जस्ट क्लिक टु द भिडियो लिङ्क एन्ड यु क्यान गो एन्ड वाच बाई योर सेल्फ है इन योर हाउस मैले यो चाहिँ तपाईँको स्लाइडहरू राखेको छु स्लाइडमा चाहिँ यो भिडियो लिङ्क पनि छ सो यु क्यान जस्ट गो एन्ड क्लिक इन द भिडियो एन्ड वाच फर्दर इन्फर्मेसन है नाउ लेट्स सी आवर भिडियो मैले चाहिँ फर इजियर प्रोसेसका लागि चाहिँ के गरेको छु भने भिडियो चाहिँ डाउनलोड गरेर राखेको छु जसले गर्दाखेरि चाहिँ के होस् भन्दाखेरि तपाईँहरूलाई चाहिँ थोरै सजिलो होस् कि जुन चलिरहेको बेलामा चाहिँ हामीले बफर गर्नु नपरोस् भनेर चाहिँ मैले भिडियो सेयर गरिदिएको छु सो नाउ लेट्स हजुर
सर बस भनेको एउटा राउट हो कि एउटा अब्जेक्ट हो डिभाइस
एउटा तपाईँको चाहिँ के हो भने ठ्याक्क वे पाथ वे हो कि तपाईँको इलेक्ट्रिक सर्किट आखिर कम्प्युटरमा जेसुकै ट्रान्सफर भयो भने इलेक्ट्रिक करेन्ट चार्जहरू ट्रान्सफर हुने हो है अरू त्यो बाहेक अरू केही पनि ट्रान्सफर हुँदैन 1 0 भए पनि तपाईँको डिजिटल लोजिकले चाहिँ के गराउँछ भने त्यसलाई चाहिँ इलेक्ट्रिक करेन्टमा पास गराउँछ सो इलेक्ट्रिक करेन्ट चाहिँ पास हुने वे हो अब यहाँ तपाईँले अझै राम्रो तरिकाले तपाईँ क्लियर हुनुहुन्छ एकचोटि यो मैले भिडियो सेयर गरे पछाडि भिडियोमा राम्रो तरिकाले डिस्क्राइब गर्छ
इन दिस भिडियो
आवाज सुनिरहेछ
Yes, sir.
No. So now let's take our attendance first, then only we will see the video. So roll number 1.
Present, sir.
2.
Yes, sir.
3. Secure. The bus is a communication pathway that allows the data to be transmitted into to a computer. One way.
Inside a computer. Understanding how buses work will give you a better understanding of what you can achieve with a computer. This will help you determine where potential bottlenecks in system performance may occur when the computer is put under load. To start with, let's consider the question, what is a computer bus, or as it's better known, a system bus? A bus inside a computer is essentially a group of electrical wires that carry a signal. On a motherboard, these wires are called traces. The bus carries data, but you need to control the movement of the data to determine where it is going. In order to do this, a typical system bus is divided into three parts. The first part is the data bus. This bus carries the data. A computer bus works just like a regular bus used to carry people. The regular bus will have a limited number of seats. A system bus will have a limited number of bits it can send at once. For example, a 32-bit bus can send 32 bits at once. Think of it like a bus with 32 seats, and in order for the bus to leave, it needs to have all 32 seats occupied. A 32-bit bus always sends 32 bits of data at once, no more, no less. The next step is that the data needs to know where it is going. This is achieved by using the address bus. The address bus essentially tells the computer where the data is going. For example, going to the main memory or to memory on a device. More on that later in the video. Last, the control bus determines when data is sent. Without any control, the computer would not be able to determine when data is sent and when it is complete. Previous data would get mixed up with the new data, and thus transfer errors would occur. To understand the bus better, let's consider a simple example of how a bus may work. In the old days of computing, this is how buses worked. Later in the video, we will see the problems with using a bus designed like this and how modern buses work differently to overcome these problems. To start with, let's consider there are 16 wires for the address bus. This will allow us to access 64 kilobytes of memory. Not a lot by today's standards. Now let's consider that we have a 16-bit data bus. 16 bits can be sent or received on the data bus at once, which is 2 bytes. Lastly, we have our control bus. In this example, there are only 4 wires. This is a simple example, and you would generally have more. But for this example, there is read, write, transfer, acknowledgement, and a clock signal wire. The clock signal will determine when data is sent. The read and write wires determine if data is being sent, used inside a computer.
and the transfer acknowledgement wire determines if the data went through okay. So essentially, set the address bus to the address you want to read or write to, place or receive your data on the data bus, and use the control wires to determine when to start the transfer, what sort of transfer, be it either read or write, and if it was received. This is a very simple example that you may find in a very old computer, but it is not without its problems. Consider that with this example, we have 36 wires. Consider now that we wanted to send 32 or 64 bits at once. This would greatly increase the number of wires required. However, having extra wires is not the only problem this would create. This brings us to the topic of serial versus parallel. Serial transmission is when the data is transferred using one channel. Each bit follows the previous bit, as in follow the leader. Parallel is when multiple channels are used at the same time. Think of it like line dancing, where everyone is in a line and dancing in sync with each other. In the old days of computing, serial was the first technology to be used, but was very slow. In order to improve speed, multiple channels were combined together to increase the speed. It makes sense, as sending more data at once greatly increases speed. Thus, old computers started using parallel transmission to increase speed. Consider this example. There are 4 bits being transmitted. The first using serial and the second using parallel. There is a small gap in transmission in between the bits. It is difficult to precisely time electronics at high speed, so sometimes there will be small delays in transmissions at high speed.
Now consider our line dancing example. If you were to speed the music up, everyone in the line would need to match the music. As the music gets faster, this gets harder and harder. With parallel communication, all data must arrive at the destination before any more can be sent. If all channels are not exactly in sync, the transmission needs to slow down to keep it in sync. This limits the speed parallel can run at. Essentially, faster parallel communications require each channel to be precisely timed with each other channel. Now consider you have 64 channels. That is a lot of channels to have precisely timed with each other. If the channels get out of sync with each other, this is referred to as clock skew. In the case of serial, if you consider a follow the leader example, if a person in the line were to go slower than the others, the effect would be that everyone behind the person would also slow down. It is a lot easier to time one channel than trying to keep multiple channels in sync with each other. As electronics improved, serial communication speeds increased and thus started getting faster than parallel communication. For these reasons, serial transmissions have started to replace parallel communication. In newer computers, you will find serial communication has replaced parallel for most of the buses in the computer, including the buses from the CPU. This allows higher speed and also requires less wires to connect devices together. Memory modules still use parallel communication. Maybe one day that will change, but you will find that just about everything else nowadays is serial communication. To better understand how serial communication works, I will use PCI Express as an example. There are a number of different ways that serial communication can be implemented. However, you will find that they are similar to how PCI Express is implemented. In this example, I will use the PCI Express by 1 slot. This slot only has one lane of traffic, making it easy to understand. Each PCI Express slot has a number of pins for power and other functions. Each lane will have 8 wires that are used for data transmission. The first 4 are for sending data. Of these 4 wires, the first 2 are for sending, and the last 2 are ground wires. In some cases, there may only be one ground wire, and the second wire may be reserved. You may be wondering why there are 2 send wires when it is using serial communication. The reason is that the 2 wires are run next to each other to reduce data corruption from interference. When sending data, the difference between the 2 signals is measured. Since both wires are next to each other, they will both equally be affected by interference, and thus the difference will remain the same with the interference quite high. Running an extra wire is a small price to pay to reduce interference and thus increase the amount of data that can be sent. The same principle applies to the receive wires. 4 wires, 2 of which are for receiving and 2 are for ground. Using 2 receive wires electrically reduces interference and thus increases the speed data can be transferred at. In old buses, to save wires, the bus may work in both directions. Essentially, a switch would be flipped to determine if the bus was receiving or sending. Nowadays, you will find that buses will use separate wires for sending and receiving. The next point to consider is how data is sent from the PCI Express slot. The way this is achieved is by using packets. A packet contains a 96 to 128 byte header and a variable length amount of data, up to 4 kilobytes. The data sent is always in multiples of 32 bits. The header contains the address and other configuration information. All data sent contains extra bits which are used for error checking. The version of PCI Express being used will determine how much extra data is needed for error checking. Having the address in the header means separate wires are not required for the address bus, as would have been required in previous computers. You can see that using serial communication has significantly reduced the number of wires required. If you want to increase the speed further, you just add additional lanes. For example, with a PCI Express by 16 slot, there are 16 lanes of traffic going into and out of the slot. You will notice that there is no wire for the clock signal. With PCI Express, there is no external clock signal since the timing signal is embedded in the data signal itself. This is one of the big advantages of serial communication. Since data does not need to line up with the clock signal, it does not matter if the data traveling over it runs at slightly different speeds. The other end will simply process it at the speed it receives it. The next point to consider is what happens when you have multiple devices, chips, and buses, which are connected together. Here there are potential different devices of different speeds, and there may be large amounts of data being transferred around. In order to match the speeds between different devices and components, buffering methods and wait states are used. Consider this example. Note that you have a North Bridge chip. The North Bridge is connected to the CPU. In this example, there are two conveyor belts which represent data channels. The two conveyor belts are exiting the North Bridge, which transports data to the GPU and the South Bridge. Since the GPU, or graphics processing unit, requires a lot of data, it is not uncommon for it to be directly connected to the North Bridge or the CPU itself. As the CPU is the fastest component in any computer system, it will be sending data to the North Bridge quite fast. The buses to other components will be slower than the CPU, and therefore, in order to match the speeds, a buffer is used. Essentially what happens is, as the data comes in, the North Bridge takes the data from the buffer and places it on the bus. If the buses are slightly out of sync, the data stays in the buffer until it can be placed on the bus. By having small delays in the buffer, this gets around the buses being out of sync with each other. The problem occurs when the buffer is full. When this occurs, the incoming data needs to be stopped, otherwise it will be lost. This is done by sending a control signal to the bus telling it to stop. This is called a wait state. Once the buffer is freed up, the bus starts again. The CPU, being the fastest component in the computer, is often placed into a wait state. A number of different design techniques are performed to prevent the CPU from going into a wait state, but you can only do so much. You can start to understand why a computer can be under heavy load and for the CPU utilization to be low. The computer is under load, but the load is not in the CPU. Bottlenecks can potentially occur anywhere in a computer system. Understanding how the buses work gives you a better understanding of where those bottlenecks may occur. Sometimes because of the different speeds of buses, upgrading from SATA 2 to SATA 3, or changing an expansion card to a different slot may make a big difference to your computer's performance. Buses in the computer can be either internal or external. Internal buses are generally high-speed buses that are inside the computer. Examples include the bus that connects to the CPU, memory, and the chips, like the North Bridge. External buses connect devices outside the computer. These buses are generally slower than the internal buses. Examples include USB, FireWire, and SCSI. SCSI can be used to connect devices outside a computer. However, it can also be used to connect devices inside the computer. Some buses can be both internal and external. An example of this is PCI Express. PCI Express can be used internally in a computer and also can be used to connect devices external to the computer. You will find that in a bus that supports both, external speeds will generally be slower than what can be achieved internally inside the computer. You may also come across the term storage bus. A storage bus is simply a bus designed for the purpose of communicating with storage devices such as hard disks, optical devices, and solid-state drives. You may also come across the term host bus adapter, or HBA. This refers to the adapter or device that supplies the bus for the storage devices. The term is commonly used in servers and storage devices. To access devices, the Parallel ATA interface, or PATA, was very popular in the 80s. It was also known as IDE, standing for Integrated Electronics. There were many improvements made to it after it was introduced, so it may also be called Enhanced IDE. The interface is obsolete nowadays, but you may find that your motherboard has this connection on it. It may be any one of the three names. Regardless of what name is used, since it is old technology, modern motherboards will support all the old and new features of the interface. So if you are using a modern motherboard, don't worry about what the connection is called. It will support all the new and old features of the interface. Nowadays, you will most likely be using a SATA connection to connect the storage devices in your computer. SATA is a serial connection while IDE was parallel. Previously in computing, parallel was faster than serial. However, as computers started to increase in speed, timing parallel connections became harder to achieve. It was found that better results could be achieved by using serial connections rather than parallel. The other connection that is commonly used is SCSI. This stands for Small Computer System Interface. Traditionally, SCSI devices cost more, so you would only see SCSI used in servers or high-end workstations. The SCSI interface has changed a large number of times. Therefore, you need to make sure you have the right interface and cable for the SCSI device you are using. Traditionally, SCSI was parallel, but now it has made the change to serial. There are other kinds of storage devices that are used, but these are the main ones you are going to come across. The last point that I would like to cover is expansion cards. Shown here is an example of a PCI Express by 1 expansion card. The expansion card will receive a clock signal from the motherboard. All expansion slots have a standardized clock rate. If different motherboards used different clock rates, then a different expansion card would need to be manufactured to support each different clock rate. This now means that only one expansion card needs to be made for each slot type. This creates the problem that the manufacturer is stuck with that clock rate, and it may not be suitable for their needs. For this reason, you will find that a lot of expansion cards will have their own crystal oscillator. A crystal is used to generate a clock rate. Having a crystal on the expansion card allows the manufacturer of the expansion card to create their own clock rate totally independently of the clock rates used on the motherboard. The expansion card will still need to sync its transfers up with the clock rates applied by the motherboard. It does this using buffers and wait states as in the previous example of the North Bridge. In order to power the crystal, the expansion card receives 12 and 3.3 volt power from the motherboard. This will be the first set of pins found on the expansion card. Not all the pins will be power, but a large number of them are. This power allows the expansion card to power the crystal to generate its own clock cycle. You should now understand that a computer system uses a number of buses for devices to communicate with each other. Buffers are used so different speed devices can communicate with each other. If too much data comes in at once, a wait state is used to temporarily stop the data from being transmitted. This concludes this video from IT Free Training.
ल ओके, यहाँसम्म तपाईहरुलाई कसैलाई के प्रब्लम छ?
serial ATL